So the second video, we're going to start talking about the regular expressions library. Import RE is what we're going to use. So RE dot whatever is if we're going to start using things inside the regular expression library. It's this mini programming language, very, very powerful, moves easily over to different languages as well. Like you can use it in R. I believe C has a version of regular expressions. Java has a version of regular expressions. So just understand that getting familiar with this library is, for me anyway, important for you guys, because if you're a data scientist at some point, you're going to need to know how to manipulate text. If you're an operations research person, at some point you're going to need to know how to manipulate text, and this is a very powerful way to do it. So this video will discuss this regular expressions library to deal with these strings and texts. All right, so let's just jump right in. Here, let me restart the kernel here. And import re is the only thing that we need. And then in order to be able to show you some of the capabilities of it, we're going to use this. So I'm going to get you familiar with some of the things that we're going to use today. Text to search is one of them. File contents is another. It's going to be another variable over here. Email is going to be another variable. All I did was I took one of my emails and saved it as a text into this folder here, so we'll be able to do some things with that. And I don't think we're going to do it in this video, but maybe the next video. And then you see a whole bunch of videos. I'm not obsessed with myself. I just wanted to have a whole bunch of different ways to pull that out. And you'll see some URL stuff in there. So I just want to be able to show you some of the power that the regular expressions can, this library can do for you. So that's what we got. So if you pull up the text to search, this is the one we're going to use mostly, and then we'll build our own little regular expression. In here you see the meta characters, and so we'll come back and look at those. Those are the ones that need to be escaped if you're trying to do a literal version of it. So the first thing that we talk about is a raw string. So what is a raw string? If I clicked on this and hit F9, this is not a raw string. So this gets printed out exactly like you would think, right? So that'd be a new line, a new line, a new line, a new line, and a tab, and then those letters. So you got a new line. So it did the regular string. It did that part first, and then new line, new line, new line, new line, then a tab, and then it printed out those characters. If you just wanted to see the /n, 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 and all that business, what you would do is put a little R out in front of it, just like we did with the F when we put that in front of the string and called those F strings, and then we could pull variables in. In this case, I don't want it to do those new lines or whatever. I want this to read as a raw string. And so you can see that it just prints out exactly what is in between the two single quotes. Okay. So that's raw strings, and that is the way that we're going to build our patterns. We're going to use raw strings in order to do that. So everywhere you see me doing this, using this compile function out of the regular expression library, you'll see an R that's associated with it. So just know what that means. So that's my pattern. I just built an object called pattern. Now you can't see it over here. It doesn't show up, but we know that we just built that pattern. And the next thing I'm going to do is I'm going to find all the ABCs, right? So if I did that, what this does is this matches in this case, it finds and it creates an iterator. So it has this matches has all of the matches where A, B, or ABC is at in our text to search variable or string. So if you came up here to text to search, you would see that this is the only place where that's located, right? There is no ABC next to each other anywhere else. So that's why only one of them came out. And this is basically the way we're going to do it. We can also do what's called a find all. So you see a find all in this case. And then what the dot represents, it's a meta character that says, give me every single character other than, I believe the only thing that's not printed, and you can look at this up in the documentation, the only thing that won't be printed is a new line. So let's highlight these two and hit F9, and I don't see any new lines or tabs or any of that business in here, but every other thing. So even spaces are in there. So A, B, C, D, so you can see all the letters that we have, and then there is a new line in between there, but you don't see it there. and then it goes through Z. But the reason why I bring this one up is because you can do the find all, and it puts it into a list instead of an iterator. We're gonna learn how to get the information out of an iterator here in a few minutes, but I just wanted you to see sort of what find all does. It puts everything that it found into this list, and I could, I just printed matches. So matches has this, so we can find it up here. You can see matches has 340 things in it. There must be 340 sort of printable characters in there, and there you go. So that's a meta character. So what do you think /D is if you had to guess? Well, it's probably just digits, if I remember correctly. Yep. So that's all of the digits that's in the file. Let's see. Let's go capital D. So capital D is I want to say the opposite, but it's really the negation of it. So it's instead of all the digits, it's everything but digits. So if we hit F9. You can see that even the /ns are in there because it's not a digit. So anything that's not a digit is in here. So that's capital D. And again, you guys could do this yourself and see what happens. I believe the /W is every character, maybe alphanumeric character. That's what it looks like. So all the ABC, all the capital A's. I don't see any new lines. I don't see any commas. I don't see any of that stuff. So it looks like it may be every alphanumeric character. And if you did /W, well, there you go. /W is the negation of that. So it's the opposite or the other characters besides these. And you can see it has /ns in there, the spaces, the dashes, and so on and so forth, right? So you guys can experiment with that yourself. And then the /S is the spaces in the new line. So all the white spaces. So all if there was tabs in there, you'd see the tabs in there as well. And then the /S is all of the characters that are not these. So the negation of that. And then that's all the other characters. Okay. You sort of got to understand what these are doing in order to be able to build these regular expressions when we get to them later. So that's why we have to introduce them and sort of go step by step. All right, the next thing we want to talk about, it looks like, is anchors. So I'm going to talk about the anchors. The /B is the most common anchor. And the way that we're going to introduce these anchors is we're going to find haha, right? So if we go back up to our text, I just want to make sure that we see. So I have ha and I have haha. So if I just do a literal search of capital H and A, I should get 1, 2, and 3 of those, right? So and it'll give you the location of it if we use the find editor. So let's do that one. Control. So I'm just going to copy this. I'm going to paste it down here. And we're going to then just do a literal search of ha. So hopefully that returns the 3, and it does, right? So if you look at 67 and 68, 70 and 71, 72 and 73, you can see where all the ha's are located. Suppose that we don't want all of the ha's. Suppose that we want the only ones that begin the word, right? So if the ha's in the middle, which this one would be in the middle, what if I only wanted those two? I only wanted a ha if it's at the beginning of a word. So how do I do that? Well, you just got to tell it I want a boundary, I want an anchor, I want the first thing to be the beginning of a word, and that's all that means. That's what this anchor means. All right, so let's print that, and we see that we didn't get this third one, right? We only got the first 2. Suppose we only wanted ones that were actual words themselves, right? So I don't want any haha. If it's not just ha, capital H and A, then I don't want it. So this should give us just that first one. So let's find out, make sure. Right, so I've put a boundary on both sides of ha. Oh, what if I only want the ones that that are at the end of the word? Well, you could do the same thing there. And you can see you get 67 and 69, and the first one is in the, oh, yes, because the first one is the end, but you don't get the one in the middle, right? You don't get the one at the beginning, you get the ones at the end. All right, so that's the most common one is the word boundary. The capital B is the not a word boundary. So there's possible that I don't want this thing to be. Oh, well, let's see what it does. Let's put it so that slash B. Let's think about that for a second. Which one of these is going to come out? So is there not a word boundary? There is a word boundary, so that one's not going to come up. Is there a word bound? No, yet there is a word bound. So the only one that should come up is this one, I think. So let's make sure that's true, right? So the only one that came up is the last one because there is no word boundary to the left of that last ha. Okay, and then these other two, I can't see a big reason. Maybe I haven't found one yet why I would want to use this, but if you were passing in a smaller string, I guess maybe one line at a time, then you'd be super concerned with the very beginning of the string, and that's what one of these represents. This one represents the beginning of the string, and the dollar sign represents the end of the string. So if I put the caret here, there's going to be nowhere where this thing is at the beginning of the string. Okay, so I got nothing. I think the beginning of our text to search string is a slash n. So maybe. Let's see. Yes. Okay, there you go. So it'd be 0, 1 and be a slash n. Okay. I'll leave that one in there for now. Okay. So that's anchors. And the next thing that we want to talk about, I believe, is, before we talk about that, because I'm going to go to the character sets, I want to just do a phone number. So we know what the pattern of a phone number looks like. We know it's a digit, a digit, a digit. So a digit, a digit, a digit. And then some character, right? It could be, so let's go back up to our, you know what? It'd probably be nice if I just print this thing on, or copied or double clicked on it. Let's go to text search. I'm gonna put it over here and hopefully it doesn't go away. Good, so it doesn't go away. So I don't have to keep flicking back and forth on this thing. Let's see, where are we at? B. Okay, so I want these phone numbers. I want to, in my text, I want to capture all of the phone numbers. So you can see it's number, 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 and then a dash, number, 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 then a dot, number, number, then a star, number, number. Yeah, so you can kind of see some of the patterns. And then I even have like a 1 dash. I still want to capture that 900 number. So what you would do is then slash dot. No, it would just be a dot. I don't want a decimal there. I don't want a not a decimal or a period. I guess either one of those work. I want any character, and so that's what that represents, is any character. And then a slash d slash d slash d, right? So number, 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 any character, number, 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 any character. So I need another dot, and then I need number, number, number. So I need 4 numbers. So slash d slash d slash d slash d. Oops. And then let's look at make sure that we get all of those suckers. All right, so how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 of them. And did I get all 9 of them? Did I get the 900 number? 900, 1, 2, 3. Yep. So you see what's happening when I run this code. All it's doing is looking for that pattern, and then any character, that pattern, any character, that pattern. All right, so let's now worry ourselves about this thing called a character set. And so what the character set is going to let us do is put in, it's like, say for instance, I don't want these stars here, and I don't want the one that has the spaces. I only want a dash or a dot. Suppose that's really what we're concern ourselves with, because maybe there's other things that, like, that means multiply or something, or maybe we have a file that has this text and some of the things in there mean something a little different, like, or space means to do something else. But the only ones with phone numbers have exactly a dot or a dash. And if that's the case, we would use this character set. So let's show how to do that. And so what you're going to do then is you're going to put inside the bracket, you're going to put in what exactly, so there's an or between each one of these things, and if it's a dot or a dash, then I want it to pick up and print out. Otherwise, I don't want it to do anything. And then this one is also, this character set is a dot or a dash, and it doesn't matter what order I'll put them in the opposite order. Doesn't matter the order, as long as one of those two, and it only looks for one. I mean, it doesn't have to be both. It's just this little bracket here means one thing that's there, and all of the things that are in there are treated as an or. So it can be that, or it can be that. So let's see what happens here. Hopefully it gives us just the ones that have dots and dashes. So you can see there's the space one went away, the 845 number went away. You know, we don't want anybody from New York calling us. The 23 number went away. Okay, so you see what happens there. So the next thing that I just want to show real quick is if, so what does this bar stand for? That bar actually stands for an or. So later on when we get to groups, we're going to need this or. But you can use it if you want in here if you wanted to. There's an or assumed in each one of these. I'm just going to show you that the or works as well, and you get the same exact thing, right? So we get the same thing we did before. So probably the smart thing to do is not include the or and just make it a sum assumed. The other thing is this caret. In this case, the caret negates, so it's the other ones besides that, right? So if it was easier for you to describe the things that it's not, then you could do that. So what is this going to print out? It should be the ones that where the dash and the dot are not. So it's just it should be just those two numbers. It should be that number and that number. So let's find out, make sure. F9, and we just get the two that it's not. Okay. What if we only wanted, so I'm going to copy paste this one below. What if we only wanted the 800 or the 900 numbers? What would we have to do then? So let's go. So it's not just any digit here. I only want the 8 or the 9. So how do I do that? You got to put a character set in here, and you got to put an 8 and a 9 right together. And then if it's an 800 or a 900 number, then I want exactly zeros there. I don't want any 845s or anything like that. And then I'm going to take this out. I'm going to put it here because I want any character. I forget, I can look over here. There are no 800 numbers where there's a space or anything else. So this would actually work either way, but I'm just going to put a dot because we're going to go back to the original one where I want to capture all of these numbers. And I only want the ones right now that have 800, 900. So there's 3 of them right there. That's an 800 number. There's a 900 number, and there's an 800 number. So this says 8 or 9, 0, 0, and then any digit, any 3 digits, and then any character, and then any 4 digits. So hopefully that works. And we get exactly what we thought. So that's actually pretty nice. Let's run it on the bigger file. Let's look at the bigger file first. Let me minus this sucker. And then pull up the bigger file. I think it's file contents. And you can see there's a whole bunch more things that it has to worry about now. All right, we can run the same compile on file. I think it's file contents. And it should have just grabbed the 800 non-numbered numbers. Okay, there we go. Let me just delete that because we already did it. The next thing we talk about is the range, or the dash. So this dash is a very special character when it's inside this character set. So this range will allow you to put just a dash and capture a whole bunch of information very quickly. So let's look at that. So let me copy paste, Control V, and then let's just look inside here. I'm going to go maybe a 1 to 5, maybe a 1 to 1 through 5. And we're going to do file content. So I want the bigger file, so I have more of a chance of this actually happening. Check out what this is doing. This says give me all of the matches that have 4 numbers in a row and all of them are less than 5. And then you can come over here and see, well, those numbers are between 1 and 5, all those numbers are between 1 and 5, and so on and so forth. So that's pretty, I don't know, I think that's pretty neat that it's able to do that. What if, let's give another example of the dash, right? So now I'm down here. Let me copy this, paste it down here, and instead of file contents, we're going to go text, do search. I believe text to search, and then I'm going to change this to maybe some letters in a row, A through E, A through E, A through Z, and A through just lowercase. All right. So let's real quick check this out. So this says any letter between A through E or any letter, capital letter A through E. So that's one character set. So it's looking for, does it match that? And then it's going down to the second level. If it matches this, then it's going to check to, is it any lowercase letter? And then if that's true, then it's going to match this next one where any letter between A and E. So let's find out. I don't know off the top of my head if there's any of them that match this. So let's see. Yes, it did. All right. So check out ABC matches that. ETA matches that. CHA, 8, ED, and so on and so forth. You can see how this thing matches. Okay, so that's just another example of how that dash, how powerful that dash can be. And so I don't have to put A, B, C, D, E. You know, I can just say A through E. All right, what if I wanted to do something like this where give me all of the, let me copy paste this real quick. Give me all of the letters that end in AT, because remember, let me pull it down my, let's see, no, that's working. Oh, there it is. That's what I'm looking for, this guy. I want to come down here and I want to pull up all of these 3-letter words at first. We got to do some more stuff in order to get the 4-letter word. But right now I want all the 3-letter words that end in AT, and but not include bat. So that's what I want to do. Copy paste. Yeah, I did. I can get rid of this. So we know that we want maybe AT and then end. I mean, we want it at the end. In other words, I just put a boundary at the end. So AT at the end of the word. Let's see if how many of those are out there. All right, so it has a whole bunch of them. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9? Maybe 1, 2, 3, 4, 5, 6, 7, 8. Now it looks like those are the only. So these are the only words that end in AT. But so we're in a decent position right now. Let's see. You know, if I wanted to make it a 3-letter word, we could do any letter. Oh, let's see what that does. And we'll correct it. So hat, fat, set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you notice that stat's not coming through, but bat is. So I want to get rid of bat. So how can I get rid of bat? Let's think about that for a second. Remember those character sets. So I put a character set in here, and I put a B in, but if I just ran this, so let's take this part out. If I just ran this, it would only give us bat probably, right? But remember what the caret does up here. Remember when we started talking about the caret? It does everything except that. So if we don't want the bat, then we got to put that guy in, and then if not, and then you get all of them. Hopefully 3, 4, 5, 6, 7. So there's 8 of them now. So that's good. And then you'd probably want to, if you want to make sure that it's 3 letters, then you put a word boundary on both sides of these, and then you're getting all of the ones that end in AT, right? So it's going to give us the same thing. It just so happens that there were no other ones that did exactly that. All right. So that's sort of anchors and character sets and literals, right? So that's called a literal, putting the A and the T in there exactly the way I want to see it. Now what I want to do is I want to talk about quantifiers. So what is a quantifier going to be able to do for us? What if I wanted to capture stat2? So that's one of the ones that hasn't been coming out. So what we'll do is we'll copy this one, Control C, put it in here. If I wanted to capture all of the ones to include, regardless of the number of letters that came out beforehand, I would want to put a, do I need a boundary? I don't think I need a word boundary. I want all of the characters before that. I don't want bat still, but I want, so what does the star do? 0 or more. So if it's just at, I want it to happen. If it's more than one letter, so I'm going to use a star here. Let's see what that one does. So hat, fat, sat, nat, and now you got stat. So it's bringing in all. So what does the star do? It basically it's always to the left. So it's the quantifier to the left. So it's doing all these /W's. So what would happen if we took the star out? Let's find out. You can kind of, hopefully you can compare the two. So this is some letter, and then, oops, some letter, and then anything but a B, and then AT. So that's why down here we're only getting stat. So I got some letter, anything but a B, and then AT. The star says it can be 0 or more. Yes, it can be 0. So you don't have to have a letter here. In this case, without the star, there had to be a letter there. So that's why the S is the only one that came out. There has to be a letter there. Any other letter besides, so if I put a plus here, this wouldn't work either. It would just give us stat as well. Probably. Still gave us stat. But if you want to make it so that you can either have one or not, then you need the star. And let's run it again, and then we get everything, including the 3-letter words. All right, so now we want any length of word. Oh, yeah, so we just did that. So let's find the telephone numbers using quantifiers. I think that will square us away. So let me come back up here and grab the telephone numbers. I don't know, I don't care which one. C, E. So instead of using, let's see, instead of using /D/D/D, and then period, and then let's put the period here. I want to use a quantifier to do that. So how can I use a quantifier to do that? I can tell it exactly the number. So look, check out this one. So that brace 3 says, give me exactly 3 of these. So let's get rid of this. And it's always to the left. So that 3 goes along with that D right there. This 3 here, oops. It's got to be a brace, goes to that /D, and then this one would be brace 4. So this makes things a little easier and starts making things a little more difficult. Why do I say that? Because before you could certainly see that how it sort of made sense. Now that we're starting to use these sort of shortcuts, it starts to make it more difficult until you've gotten a little practice with it. So let's make sure that this does what I want it to do, and it does, right? So I get 3 numbers in a row, that anything, right? So that's what the dot means, any one of these separators, and then 3 more numbers, any other separator, and then any 4 numbers. Okay, so that's how we can use the separators. I guess let me get rid of that, move this up. All right, so that'll work there. Let's build our first regular expression, like a difficult regular expression. So let's build our first one. I'm gonna press a bunch of enter signs and get it up here. I want to now use these regular expressions just to capture the Misters in here. So Mr. Jones, and it's got a period, a Mr. Smith, and a Mr. T. So just notice how these things, and guess what? We have an MR. So you can't just use MR as the sort of the quantifier. You got to figure out how to get rid of those. So let's start off. Let's start off with just the MRs, and you can see that it has all 5 of them. 1, 2, 3, 4, 5, 6. Oh, it doesn't have Ms. Davis, so we don't have to worry about Ms. Davis isn't in there because it doesn't have an M and an R. So that literal R will take care of the Mrs. Davis. All right. Well, how do I get the period on there? So how do I get rid of maybe the ones? So let's put that in. So maybe slash period F9. So we get, so I brought in the period, but what happens for the ones that I don't want? So in other words, that don't have a period. So we missed Mr. Smith, it looks like. Mr. Smith is gone, but I have the Mr. Jones and the Mr. T. So those 2 are popping up. How do I bring Mr. Smith back in? You have to come up here and use this quantifier. Oh, where'd it go? Here it is. So the question mark. So the question mark says either 0 or 1 of these. So if I put a question mark here, where'd it go? Question mark on my keyboard, and then F9, we get the Mr. Dot, the Mr. No Nothing, and then the other Mrs. ones that come in as well. So now if I want to say, well, I want to get rid of those Mrs., what can I do then? Yeah, my microphone fell, I apologize. What can I do then? If I want to get rid of, so I need a space there. So that's what, so Mr., there's either a period here or not, and then there's a space in between the name. And that's true everywhere. So there's not a period here, but there's a space. So now I want to put in slash space. Let's run this. And you can see it's bringing in the Mr., it's bringing in the space, Mr. space. And so we have the 3 Misters that we're looking for. Now we just got to get the rest of the word. So now we want to make it a capital letter. So let's go through A through Z. Find out what happens now. So Mr. J, Mr. Jones is coming in, Mr. Smith is coming in, and Mr. T is coming in. Okay, that looks pretty cool. How do we get the rest of the word? How do we get the rest of the? How do I get the Jones to get filled in? All that is slash W. So go all the way until you reach a space, basically. Let's see here. Now that's just 1, right? So I would have to do slash W, slash W, slash W, slash W, slash W. So it would continue doing it. And the problem is, you know, Jones and T are not the same length, and Jones and Smith happen to be the same. Mr. Jones and Mr. Smith, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that would be okay, but I don't want this to be predicated on having Misters with exactly 5 names in their last. So now I have to put a quantifier on this. Which quantifier do we want? Well, if I put a plus on here, you have to have 1 or more things after. So Mr. T wouldn't come up, but the other ones would. So let's put a plus at first just to see what happens. I want you to see that this really means there has to be 1 or more. And so you get Mr. Jones and you get Mr. Smith, but you don't get Mr. T. Why? Because there was 0 after the capital T. So after this A through Z, there was nothing after it. So it did not give you Mr. T. It said, but it's not matching the pattern here. But what we can do then, instead of having the plus, is we can come back and say, well, the star lets me have 0 or more. So change this to a star. And I think we have, okay. So we have everything. We have all the Misters and we're able to go through. But this is our first real sort of complicated regular expression that we built. That's all we're going to do for today. We'll come back next class and we will cover groups, and we'll do a little bit more complicated ones, and then we'll even do one where that we build a variable into one of these numbers here. All right, that's all I got. Hope you guys have a great day.